I'd like to present some of the work we have done, and the object of this was we are developing a CGM system, a WaveForm Cascade CGM system. This is a CGM system that is torque-armless instruction, so it uses no needle. These are the critical components of this system, which is a transmitter, the sensor itself right here, a delivery device for the sensor and holds the transmitter, and then the applicator. So the sensor is the throwaway part. Parts of this are also the throwaway. These are reusable. The object, yes, we can, that's more than happy to pass it around and you can see it. The sensor is the small part that's right in there. And that's delivered into the skin. So it has many similarities to the Dexcom system and obviously the Abbott. We intend to be in the European market the first quarter of next year. The object of this study was to see how we performed in contrast to one of the leaders in this industry, which is the Abbott Libre Flash. The study was designed a 14-day clinical study, and there were 5 in-clinic days. Each in-clinic day had 12 hours. Each subject was in the in-clinic day for 12 hours. The blood was drawn every 15 minutes, venous blood, and was analyzed on a YSI. The analysis of the performance was based on a data pair. One is the YSI glucose values contrasted to the CGM glucose values, as is normally done in these studies. So overall, we had 10 subjects, and the analysis was basically over the 40 to 400 milligram per deciliter range in terms of concentration. If we look at the age distributions are about 40, the mean distribution of age, and then an even distribution between male and female subjects. The biggest takeaway here is obviously the analysis. So if we look at our analysis was partially prospective and partially retrospective. The analysis, the data that we generated from the Abbott, at each 15-minute period, they were requested to take a reading. That reading was written down, and that was part of the analysis process. As most of you are aware in terms of the analysis that's being done on the CGM system, one of the critical analysis is obviously a MARD, mean absolute relative difference percentage. Another one is the MAD, which is mean absolute difference. For all those values, less than 70 milligrams per deciliter, between 70 and 40. For the ones between 70 and 400, we do the MARD analysis. The other ones we do is a consensus error grid analysis of this type, and we look at how many points are in A, B, C, and D. Critically, you want as many points as possible in A and B, minimum in C, and none in D and E. That means that the process analysis that you are doing is beneficial and can be used to treat the subject. So overall, in our analysis, the Cascade CGM system had a MARD of 12.5%. The Abbott Libre, 14%. I will say, at least in the terms of MAD, ours was 13.1, but Libre was better at 9.5. If we're looking at this analysis, the consensus error grid analysis, here we have, in A, we're at 87.2, and Libre is 83.6. So part of the takeaway for us here is that we are ready to be a commercial product. We can deliver values that are useful and can be beneficial for people to treat and to use as a non-adjunctive system to deliver insulin and how they want to treat themselves. We also broke some of this data down into individual days. So we're looking at how does the system work over each of those days. Is it the same? Or is it worse? So as you look at this, effectively the marks are, sometimes they are higher at the back end, more so in some of the Abbott Libre, but on the front end, they're pretty even across the board. So what that tells us is that we can count on the system in day 1 as much as we can count on the system in day 14.